we want to find the max, mins, and point of inflections of this graph, if they even exist. Well, first step, we want to find the critical values and then decide at some point if they're max or mins. And we also have to take the second derivative to find the possible points of inflections and to decide using the second derivatives if these critical points are max, mins, and a point of inflection. So first we take the derivative. We get 3x squared plus 12x minus 15. And the number 3 goes under 3, 12, and 15. Hence, I can factor out 3. We get x squared. 3 times 4 is 12, times x is 12x. 3 times minus 5 is negative 15. Then I try to factor this. Since it's x squared in front, not 3x squared or 9x squared or negative x squared, I'll try to factor it as x followed by a number times x followed by yet another number. And the two numbers I put down, they should multiply out to the constant, negative 5, and they should add up to 4. And the two numbers that multiply out to negative 5, but add up to 4 are positive 5 and negative 1. Now, I factored y prime, and I want to know when it equals 0. Well, I know that no matter what x is, 3 always equals 3, and it never ever equals 0. When does x plus 5 equal 0? When x is negative 5. When does x minus 1 equal 0? When x is 1. It turns out that the y value is 101 when x is negative 5, and when x is 1, negative 14, negative 13, negative 7. Again, if you want to, so we have 2 points, negative 5, 101, and 1, 7. If you want a y value, please don't go and plug x's into the y prime formula. If you have an x value and you want to know a y value, go to the y formula. If you have an x value and you want to know what y prime is, go to the y prime formula. Okay. Now we need to compute the second derivative. And we have 3 different equations to pick from to take the derivative. I don't like the last one because it's a product. We'd have to use a product rule. But the middle one is nice. The 3 just stays out there. Times the derivative of x squared plus 4x minus 5 is 2x plus 4. But I can factor out a 2 from 2x plus 4. 2 times x plus 2. So this is 6 times x plus 2. And this equals 0 when x is negative 2. So, what is the y value? Well, negative 2 cubed is negative 8. Negative 2 squared is 4 times 6 is 24. Negative 15 times negative 2 is plus 30, plus 1 more. It looks to me like 47. This equals 47. Okay. So these are critical points. Negative 5, 101, 1, negative 7. But I want to know, are they more than critical points? Are they actually, are they max or mins? So what you do is you evaluate the second derivative, say at negative 5. The second derivative is right here. It's 6 times whatever x is plus 2. which is 6 times negative 3, which is negative 18, which is less than 0. That implies we have a max at negative 5, 101. Now we do the same exact thing for the other x value from the critical point 1. F double prime is 6 times x, which is 1, plus 2. This is actually positive 18, which is greater than 0. When the second derivative is positive at a critical value, you have a min there. You have a min at 1, negative 7. Now, what about the point of inflection? F double prime of x is 6 times x plus 2. Let's consider this as a number line, and here's negative 2. If x is if x is less than negative 2, 6 is positive. And remember, if you're at negative 2 and you add 2, you get to 0. So if you start to the left of negative 2 and you add 2, you'll be negative. A positive times a negative is negative. The second derivative is negative to the left of negative 2. That is, the original function is concave down. And then at 2, well, what happens if you're more than negative 2? If you're over here and you add 2, you'll turn positive. 6 is always positive. And if x is more than negative 2, this is positive. Positive times positive is positive. We have our point of inflection at negative 2. The concavity went from negative to positive. So we have a point of inflection at negative 2, 47. I got the 47 from right there.